Okay, this is a video about multiplying a fraction and a mixed number with the area model. One of the very first things that we would like students to do when they are solving multiplication here with a fraction and a mixed numeral is first to use the algorithm. Most students have learned the algorithm, and it's a nice way to check. Eventually we want them to not have to use the area model anyway, but it's a good idea to use the algorithm first and then make sure it's checked with the area model. So whenever I have a problem, my first job is going to be to rewrite it. And when I rewrite it, I'm going to try to make it so that it looks, I'm going to try to write the mixed numeral away, if you will, as an improper fraction. So 1 times 4 is 4, plus 3 is 7, and I get 7/4. When I multiply cross, I would want to first make sure, is there any cross canceling that can happen? 2 won't go into 7 and 1 won't go into 4 any more than it does. So I simply have 7/8 here, and that's going to be the answer to this. Half of 1 3/4 is 7/8. Now I'm going to use the area model to show how that works. Now it doesn't really matter what sort of rectangle I draw, whether it's squarish or rectangle, but I need to draw 2 holes that are the same. And I'm going to do 2 holes because I have one of my fractions here is a mixed numeral, which is 1 hole and part of a hole. So that means I'm going to have 1, and I'm going to have 3/4 representing here, 1 3/4. So if I have 1 3/4, right away I'm going to notice that the denominator is 4 in here, and I think what I'll do is I'll just circle that as 4. Okay, so you can see the 4, and then when I come down here I'll divide it with the same color. So I'm going to break it into 4 pieces. Now this means that this fraction, if I was just making 3/4, it would still be of the whole. I'm not going to make like 4 pieces out of the 2 holes. I'm going to make 4 in the 1 hole because I'm just making out of one fraction here, but I have 2 things. I have 1 and I have 3/4 over here. So if I'm going to first start here, that's an even number, so I break it in half, I break it down, and there would be 3/4. But I've got this other hole here, and since this is attached here to it, I have to show quarters on this one also. Okay, now if it's 1 3/4, that means that I have in this fraction, I have 1 hole. There's my 1 hole, and I have 3/4. And I'm multiplying it by a half. So I'm going to take my other fraction here. I'm going to circle this. This half means I'm going to be taking this side of this fraction here, and I'm going to be breaking it into 2 pieces and going across, all the way across like this. Now I have half shown this way. If it was just a half times 1, see if I can cover that up. A half times 1 would just be this. You know, I would have had 1 hole cut in half, but because I have 3/4 over here, I have to cut that 3/4 as well. So now I'm going to shade the overlap, and it doesn't matter. I could shade the top half across, or I could shade the bottom half across. I'll go ahead and shade the top. And I'm going to go all the way across here because it's half, even if this piece here that's not doesn't have the pink in it as well. Okay, now I knew my answer was 7/8, and that makes sense because I have 1, 2, 3, 4, and then I would have 5, 6, 7, 8. Inside of 1 hole I would have 8 pieces, and it just happens that 3 more of my pieces are over here. So I have 1, 2, 3, 4, 5, 6, 7 of the 8s. Okay, looking at number 2. Let's try this, and it would be good if your student tried to picture, you know, what is that first step? It's multiplying it before drawing it as an area. So I'm going to, what did I say to do? Always recopy the problem. In this case, I'm going to recopy it, and I'm going to change the mixed numeral into an improper fraction. 1 times 3 is 3, plus 1 is 4, so I have 4/3. This one is kind of a funny one. Can I cross cancel? That's always my next step. Cross cancel. Yeah, I can cross cancel. 4 times 1, or 1 4 goes into 4, and 1 4 goes into 4. 1 3 goes into 3, and 1 3 goes into 3. So my answer is 1 over 1, which is 1. That means 3/4 of 1 1/3 is 1, is my answer here. So now let's prove that. Again, it doesn't really matter if I make these rectangular or square as long as they are both alike. So here's 1, and here's a second one, and that's because I have 1, and I have a part of another one, 1/3, and I have to have 2 holes to show more than 1. 1 and the 1/3 is going to be over here. Okay, take this again. This says it's going to be broken into thirds. So I start with my first hole, I put my finger in the middle, and I make a couple little tick marks so that I feel like I have equal thirds. And then I have to do it with the other one. And it says that I have 1 1/3. So that means I'm going to shade the 1, which is really 3/3. We've got right here, we have 4/3. So there's 1, 2, 3/3, and 4/3 is sitting right over here. I come up here and I've got 4, which means I'm going to break this other dimension or factor, we would say. And by the way, this is a factor times a factor equals a product. So a factor is on one side here, and a factor would be the other, and the product would be the area of the two. So in this case, I've got 4. I'm going to break it into 4 equal pieces, go all the way across.